Greetings. What if I told you that something that was potentially an existential threat to human civilization, something that could have wiped out an entire continent and sent the economy into a tailspin for years, and that was a threat all the way into the late 1990s and the early 2000s, is no longer a threat at all? Would you believe me if I told you that? Well, it's true. And the threat is whether an asteroid impact hitting the Earth can catch us by surprise or not. So we go to one of the articles I wrote back on The Futurist in November of 2019. This is the article, Atom Award of the Month, November 2019. And I describe how there is now the advancement of telescopic technology. Telescopes get more and more advanced as computing power advances, and therefore we are able to detect smaller and smaller and fainter objects with greater precision. So we go to this chart over here, which takes us to the JPL website. This is the chart of Near-Earth Asteroids detected. These are called NEOs. And as you can see, in the 90s and early 2000s, we knew nothing about which asteroids might be buzzing near the Earth. In fact, in the 1990s, there were a number of movies centered around the prospect of a large asteroid hitting the Earth and destroying a large part of civilization or all of it, and how people had to minimize the damage of that asteroid. There were many films about that because in the 1990s, a large asteroid could have hit the Earth without anyone having any advanced knowledge of what to do and without there being any way for us to mitigate that damage. Things have changed in even just the 20-odd years since that time, because as telescope power increases as a square root of computing power, therefore we are able to detect asteroids that we could not have detected before. The reason telescope power increases as a square root of computing power is as the dimensions become half, the number of pixels become 4 times, as you can see from these images over here, and therefore once you have that type of progression, computerization of the data that comes through a telescope, greater computational power applied to the data gets to be used, but it advances as a square root of computing power. To get half the resolution, as in twice as good resolution, there are 4 times as many pixels, and therefore telescope power increases at a square root of the rate of computing advancement, just like video game graphics also improve at a square root of the rate of computing advancement, as I discuss in this video up here. And therefore, these asteroids are all getting detected. As you can see from this chart, the red, which are the ones greater than 1 kilometer in size, and they would do a tremendous amount of damage if they were to strike the Earth, especially by surprise. We found all of those as of 2007 or 8, and now there's very few left to still be discovered. We find 1 or 2 here and there, but this is clearly a flatlining curve. Remember the asteroid that led to the extinction of the dinosaurs and 99% of all life on Earth was 10 kilometers in diameter. An impact of that size only happens once every several tens of millions of years. But if an asteroid of that size were to impact us now, yeah, that would be very catastrophic. The more realistic threat is actually from the Orange Asteroids. These are the ones that are between 140 meters and 1 kilometer. These are large enough to cause substantial damage if they hit a densely populated area, a lot of economic damage for sure, but cannot end civilization per se. It'll just be very bad for the country that it hits, or if it hits the ocean, there'll be a tsunami and things like that. And we are detecting more and more of those. That number is still rising, and the detections are still ongoing. We're finding more and more of these, and that's why this curve is also flatlining to some extent. Remember, this should increase in a logarithmic sense. The grand total is rising in an exponential curve. The fact that the orange is a flat line shows we're getting closer to saturation here, just like we got to saturation in the red zone, meaning asteroids of 1 kilometer or higher. And then the blue are asteroids under 140 meters in size, and most of these are not a threat because the atmosphere will burn up or break up asteroids that are smaller than 140 meters for the most part. Occasionally, some of these can hit the surface, but the impact would be relatively little, not enough to truly cause a tsunami. So the blue is not really a threat, but we do keep track of these as well. And the number of these is rising the most because the telescopic precision still has a lot to find. The orange is already flatlining, and in a few years' time, the orange will be completely saturated as well, with all of these medium risk level asteroids also mapped out. Now, this is updated on the JPL website every 6 months or so. If you went back even 5 years, you were only up to here. The number was just 12,000, all of these asteroids detected. versus 27,000 today. So this threat is greatly mitigated because we have ascertained whether any big impact is imminent or not, and we can identify which asteroid, when, and what angle it is hitting from, and therefore the various strategies that could be employed to deflect that or destroy that or harness that can be used. And I'll talk about that later in the video. Now the next question on your mind, of course, is what is the next major asteroid threat? So we go back to the article on The Futurist. You can read this article and scroll down, and you'll find that I have in fact linked to another link on Wikipedia about an asteroid that is going to zoom by the Earth in 2036. It is 370 meters in diameter, so the middle of this orange range. And it's not going to hit the Earth, but has a very, very, very small chance of actually impacting. A 1 out of 45,000 chance of impacting, but it's big enough that if it impacted, it would be substantial damage. And it's in 2036. Therefore, we are observing this risk very closely. And of course, it's going to circle the sun another 15 odd times or so in the 15 years between now and 2036. So there'll be a lot more chances to observe this asteroid. But this is the one that we have to look at. So you don't have to worry about it until 2036. This asteroid is not going to hit either. It just has a very small chance of hitting. And then the strategies to defend the Earth from such an asteroid involve deflection of the asteroid, pulverization of the asteroid into a number of smaller pieces so that it burns up in the atmosphere because it has much more surface area for the same mass, just like these blue asteroids all burn up before hitting the ground. Or, more ambitiously, harnessing the asteroid, because a lot of asteroids have a number of very precious metals in them. What a lot of people don't realize is how asteroids have a lot of heavy metals, such as platinum, gold, palladium, etc. in their surface, much more so than the crust of the Earth, because the Earth, being a large object, saw most of the heavier elements sink to the center. Most of the gold in the Earth is at the center of the Earth. Very little is still in the crust. Same goes for platinum, silver, palladium, all of those others. In an asteroid, the gravity is so low, so these precious metals are more evenly distributed. And they're only precious on the Earth because they're rare in the Earth because of the mass of the Earth making most of it sink to the center and therefore be inaccessible. These asteroids have these precious metals in considerably more abundance. In fact, we have already identified asteroids that have $20 trillion worth of gold and platinum in today's prices of gold and platinum in them already. Of course, once these asteroids become accessible, the price of all those commodity metals will plunge because the supply rose so much. That is why I'm very, very against any thesis that says gold is something to invest in, or platinum or silver or any metal like that is something to invest in. And I debunk that in an economic sense in this video up here. But the atom, the technological medium of human civilization, continually finds ways to lower the cost of anything that is expensive or adapt around anything that is expensive and necessary, find an alternative to that. And that's why precious metals are the worst investment thesis of all if you're going to be long on them. If you're going to be short on them, it could actually be very good. But precious metals are among the worst. And as soon as some asteroid mining company, whether Elon Musk's company SpaceX starts to branch out into those types of business ventures or some other company, once there's even a small chance that someone's going to be able to recover gold or platinum from one of the asteroids that buzzes near to the Earth, then the price of gold and platinum and these precious metals is going to plunge dramatically just because there is an imminent increase in its supply. So this asteroid defense concept is tied to the economic business case of harnessing asteroids for the precious metals within them, or even for the hydrocarbons in them. A large asteroid that has hydrocarbons in it, that's equal to several billion barrels of oil, for example. So it's worth that much money, even if it just has hydrocarbons that can be used as hydrocarbon fuel to supplement our fossil fuel resources. So it doesn't just have to be precious metals, it can even be hydrocarbons in these asteroids. So our defense mechanism is in fact our wealth generation mechanism as far as near-Earth asteroids go. Now for some supplemental videos, I want to direct you to some other videos on this channel. Over here is a video where I talk about extinction events and in great detail discuss the 10-kilometer asteroid that led to the extinction of the dinosaurs and what happens when such an impact event occurs and how life reverts back to the trend line and all the other diversions of the evolutionary stream that occur as a result of that. And over here, I talk about how telescope power has been rising exponentially because telescope power is another thing that has been computerized and therefore has been converted into high tech. Something that was low tech is converted into high tech, and telescope precision rises as a square root of computing power progression, as I discussed before. So those are also videos you should look at. But an asteroid hitting the Earth is something you absolutely just don't have to worry about anymore. This is now late 2021 going into 2022. In the 1990s, there was a threat that some huge asteroid could hit us, and we would not have known about it until just minutes or seconds in advance. Now that threat has gone away. We have detected the vast majority of asteroids that could hit us, and that number is rising all the time. It's just not something to worry about anymore at all. So I hope you found this video to be informative, and I hope this leads you to research some of the other topics that this video has perhaps directed you to look into further with all the tiles that I put into this video. And thank you very much for watching.